Dear students, today we see about Proell governor, determination of speed and sensitivity for Proell governor. So for this experiment, aim of the experiment to determine the speed and sensitivity of the Proell governor. So first we know about the governor. Governor means to regulate the speed of the machine. So for every rotational moment we are going to regulate means at the place we are going to use the governor. So for this purpose, this is the setup for the experimental setup for the Proell governor. Proell governor means we have the wings ball and center load. So this setup is known as the Proell governor. So the apparatus required: experimental setup, speed controller, tachometer and scale. So this is this apparatus required. So basic specifications for the governor: length of the each link 0.125 meter, initial height of the governor h0 is equal to 0.094 meter, and initial radius of rotation r0 is equal to 0.136 meter. Weight of the each ball is 0.6 kg. Extension length is Bg is equal to 0.5 kg, and extensions of the length Bg is equal to 0.7 kg, and height we have a height formula: h is equal to h0 minus x divided by 2. Here x is equal to height of the governor, h is equal to h0 minus x divided by 2. So x means sleeve distance. So sleeve distance we have to find the h, and radius of rotation r, small r, is equal to 0.05 plus L sin alpha. So this is the formula to find the radius of rotation and height of the governor. And then we find the centrifugal force. Centrifugal force is equal to W divided by G into omega square into R. Omega square is equal to angular velocity of the governor, and R is radius of rotation, and weight is W is equal to weight of the governor and gravity. So this is the formula to find the force, centrifugal force value. So this is the stabilization for the Proell governor. The first column is speed, and second one is sleeve displacement, and height of the governor and radius of the rotation, and force, centrifugal force. For the speed we are going to use the tachometer, and sleeve we are going to measure by using the scale, and height we have the formula, and radius of rotation also we have the formula. Finally we calculate the centrifugal force of the governor. So now we do the experiment. So now we are going to switch on the power supply. The power supply plug is connected to the speed controller, and speed controller we connected with the motor, DC motor. So we gradually increase the first switch on the speed controller and gradually increase the speed. Gradually increase the speed. When the sleeve is moved upward at the speed we are going to note it. So this is the initial displacement speed. Okay, now we are going to take the speed value from the tachometer by using the tachometer. So this is very important caution, because the rotational movement ball is rotated with particular speed. So we are going to carefully fix it with the center hole of the shaft. So this is the value for speed for initial displacement of the sleeve. So we find the value, speed, and we are going to measure by using the scale. So for this sleeve initial displacement of 5 centimeter, that means 0.5 meter. So we take the speed and displacement value from the measurement. So this procedure we do the 4 times. We gradually increase the speed and then take the sleeve displacement, and we based on the sleeve displacement and the speed value we calculate the height and radius of rotation and force, centrifugal force of the governor. So result, a different motor speed we going to sleeve lift are noted, and corresponding governor speed and sensitivity are calculated. Thank you. So next we similarly do the same procedure for the Porter governor also. So same as well as the Porter governor and Proell governor, we have the same specifications, same formula and same tabulation. So for this Porter governor we change the setup for the experimental setup. For this Porter governor we remove the balls from the links, and then we calculated speed and sleeve distance. Based on the sleeve and the sleeve distance and the speed, we going to calculate the height and radius of rotation and then centrifugal force. These 3 values we going to calculate it by using the same formula. Then result. So and also we follow the graphs for the sleeve displacement versus radius of rotation, and force versus radius of rotation, and speed and versus sleeve displacement. These 3 graphs we going to follow. Result, at different motor speed and sleeve lift are noted, and corresponding governor speed and sensitivity are calculated by using the Porter governor. Thank you. So next, dear students, today now see about the determination of speed and sensitivity for the Hartnell governor. So Hartnell governor, we some changes from the specifications. So the dimensions, length A is equal to 0.79 meter and length B is equal to 0.135 meter, and weight of the ball is equal to 0.6 kgs, and initial radius of rotation R0 is equal to 0.163 meter, spring stiffness 2 kg per centimeter, free length spring to 0.10 meter, and R is equal to, that means radius of rotation is equal to R0 plus X into A by B into M. So here X is equal to sleeve displacement and A by B means length of the Hartnell links, and then angular velocity omega is equal to 2 pi n divided by 60 radian per second. So next we go for the tabulation. Speed and first column is speed and second column is sleeve displacement. From the sleeve displacement we are going to calculate the radius of rotation and centrifugal force. Here there is no calculation about the Hartnell height of the governor. So same as well as the we are going to follow the 3 graphs: sleeve displacement and radius of rotation, force and radius of rotation, and speed versus sleeve displacement. These 3 graphs we are going to follow and draw the graphs. Finally we find the force and sensitivity of the Hartnell governor. So result, thus the at different motor speed the sleeve lift are noted and the corresponding governor speed and sensitivity are calculated. Thank you.